Okay, so we got an example here. Y double prime minus 9y prime equals 9x times e to the negative 3x. Well, from the characteristic equation of the homogeneous, we got m equals negative 3 and 3. So our complementary solution, y equals c1 e to the 3x plus c2 e to the negative 3x, which isn't a problem. Now, that means here's our y1, here's our y2, here's y1 prime, here's y2 prime. Those are the entries in the coefficient matrix, and so the determinant of that coefficient matrix will be the denominator in our Cramer's rule. And we will replace 0 and the right hand side, 9x e to the negative 3x, in that, and then evaluate this determinant and this determinant. We get negative 9x times e to the, so we got 0 here, and here we got negative 9ex e to the negative 6x. And the determinant of this, if you multiply this times this, we get negative 3 e to the 0, and this is also negative 3 e to the 0, so we get negative 6. So this is our u1 prime. Call it 3 halves if you want. So our u1 would be the integral of that, okay? And yeah, you can do this with integration by parts. I just use my software to do it, but if you do integration by parts, you'll get negative 4th x times e to the negative 6x minus 1/24 times e to the negative 6x, and that is our u1. Similarly, replacing this column in our denominator determinant with the 0 and the 9x e to the negative 3x. We've got u2 prime equal to this determinant over this determinant, and this one is, let me see, 9x times e to the 0, so 9x minus 0, so just 9x, over the negative 6, that's going to be the same both times. So u2 is negative 3 halves times integral of x dx, so negative 3/4 x squared. Negative 3/4 x squared. So now we've got our u1 and our u2. Well, yp is u1 times y1, and and plus u2 times y2. So this was our y1, here was our u1, this was our y2, here is our u2, and if we simplify all this mess, you see we have got this, actually we don't have much we can simplify there, but multiplying this out, negative 1/4 x e to the negative 3x when you multiply this by this, see? And multiplying this by this, we get negative 1/24 e to the negative 3x, and then this part just is as it stands, negative 3/4 x squared e to the negative 3x. But that's our yp. So here is a solution to the equation, yc plus yp. Here's the yc, and here's the yp that we just found using variation parameters. We're noting, now careful about this, here's something you must be cautious with. This term right here is a constant times e to the negative 3x. That term will absorb this term right here. The constant will take care of our negative 1/24 e to the negative 3x. That will be absorbed into the c2. So the real solution is c1 e to the 3x plus c2 e to the negative 3x minus 1/4 x minus x e to the negative 3x, and then minus 3/4 x squared e to the negative 3x. Whew! Me too.